So here's our part two. It's an example of one of these percent yield problems that has a little bit of that cautionary tale. And this will be a quick one. It's really just a problem. But this has to do with a common mistake that students make when doing percent yield problems, because percent yield is actually a pretty easy equation or whatever. Yeah, I guess that's the right word, right? Let me make this a little bit smaller so I can actually use it today. But here's what times students will do is they will look at this particular equation, right? You got 24.5 grams of nitrogen reacting with 21.7 grams of ammonia. What's the percent yield of the reaction? And so students will look at it and go, percent yield equals actual, if they do this much, theoretical, times 100. And then they'll look at it and go, okay, I've got two numbers, 21.7 divided by 24.5 times 100. And they'll go 21.7 divided by 24.5 equals. And they'll say, all right, that's got to be equal to 88.6% yield. Done. I'm stoked. So word to the wise. This is Chem 2. It's an honors class. This is like AP. If it seems like it's too easy, yeah, it's too easy. This is not how this is done. That's why this is called the cautionary tale, but it's a very common misconception. Yeah, you kind of did some numbers in there and you divided and you got a percent. But this percent is utterly meaningless. And here's why. These are two different compounds, right? 24.5 grams of nitrogen, that's this stuff, N2, and 21.7 grams over here of ammonia. This is NH3. You can't do that. Literally, this is apples and oranges. It's actually ammonia and nitrogen. But you cannot do percent yield problems with two different chemicals. When you're doing actual yield and theoretical yield, they both have to be the same product. In this case, there is only one product, but you could potentially have an equation where you've got two different products and your top and bottom numbers have to be the exact same compound. This is an important piece in doing these. So let me clear off my screen so I can actually use this so we can do this problem clearing from page. So here's how we actually do this particular problem. Because again, it's not hard, but it is a stoich problem. So maybe you should hit pause, see if you can figure it out. But this is a stoichiometry problem. In order to do this, if we need percent yield, sorry, my lines are not very straight, percent yield, right? We need to know actual, and then we need to know theoretical yield. Our theoretical yield down here, that's stoich. You have to do a stoich problem almost every time first. So we need to know what this is supposed to be before we calculate what our percent yield was. We have not figured out our theoretical yield yet. So starting off, 24.5 grams of nitrogen, 24.5 grams of nitrogen. This does not mean that our theoretical yield here is 21.7 grams. That's not theoretical, that's actual yield, because it says those grams are recovered. That's what I've collected. So I need to figure out on paper what my theoretical yield was supposed to be. So this is where the stoich part comes into play. So again, that 21.7 is not the theoretical yield. That's the actual yield, just because of the way that the language is written on there. So we got to do our stoich first. So 24.5 grams of nitrogen, N2, because there's our equation up there, right? Grams to moles, grams of nitrogen to moles of nitrogen. I'm going to mention this one as well because this is also a common mistake that students make. Remember that the molar mass of nitrogen includes two atoms of nitrogen, not just one. So it's 14.01 times 2 when you do this, 28.02. Grams of nitrogen gas is 1 mole of nitrogen gas. So again, make sure that you include the full formula when you're doing your molar masses. Don't just do one N because it's actually N2. All right, second step, moles to moles, moles of N2 to moles of our other material. Are trying to go for theoretical yield, so we need to go to our product, 2 moles of NH3. Again, our mole to mole ratio, 2 moles of NH3 can be produced from 1 single mole of nitrogen gas. And then the last step is moles to grams. Moles of NH3 to grams of NH3. Okay, with this one, again, make sure you do your full formula. 1401 plus 3 hydrogens, 3.03, gives us a total mass of 17.04 is the molar mass of ammonia. So do your calculation there and figure out what that's going to be. Again, multiply across the top, divide by the bottom. 24.5 times 2 times 17.04. I multiply it across the top. Now I divide by each thing on the bottom. There's a 1 there, which is just divided by 28.02. And I get 29.07987, blah, blah, blah. So rounding for sig figs. 3 sig figs in my problem, 3 sig figs in my problem. I want to do this as 3 sig figs as well. 29 point, that rounds to 8, 29.8 grams of ammonia, NH3. This is our theoretical yield. Now we can go back and do our percent yield. So our percent yield is actual. What did we really recover? We recovered 21.7 grams divided by our theoretical yield, which is 29.8 grams. Again, this is actual. This is the theoretical. On paper, we should have gotten almost 30 grams. We really only collected 21, almost 22 grams. So again, you've got to make sure that you've got actual on the top, the truly recovered part, divided by the calculated amount. What did you think you were supposed to get? So 21.7 divided by 29.8. If I did that right, yep. Times 100, again, times 100 because it's a percent yield, equals, with our 3 sig figs, 72.8 is our percent yield for this reaction. Again, it's definitely different. You can't just grab the 2 numbers that's in the problem. You have to read the problem. Make sure you know that both of those numbers are both part of the product. If you have a reactant and a product, that means you have to do stoich first to figure out your theoretical yield of product, and then you can do the percent yield. So there you go, an example of a cautionary tale for a percent yield problem. Hope you liked it. See you guys later.